Hi there, my name is Mitch Charalambidis, and in this video we will start talking about rational functions, and more precisely we will refer to the zeros of a rational function. But since we'll start talking about a rational function, let me quickly give a definition of a rational function. A rational function is a function that is expressed as a fraction of polynomials. So you get two random polynomials px and qx. And then if you put them in a fraction as px over qx, that function is called rational, regardless of the degree of each of the two polynomials involved. For instance, 3x over x minus 1 or x squared minus x over 3x minus 10 or x squared plus x over x cubed minus 2x and so on. Any two polynomials being divided to each other, then these two form a rational function. Now, let's talk about the zero of a rational function. In general, if you remember from previous videos, the zero of a function f of x is the value x0 for which f of x0 is equal to 0. So 0 to a function is that number that produces as the output value, as the corresponding y value, the number 0. Now that we have a rational function, and I said before that a rational function is a fraction of polynomials, in order to find its 0, we should make that fraction equal to 0. But remember that a fraction is equal to 0 only when its numerator itself is 0. So, what could we conclude from here? That to find the 0 of a rational function, I just need to take its numerator and make it equal to 0. So that's the theory that we will have to follow. Of course, let's put a small note here and we will see that in the next video in more details. It should be, the zeros should be values within the domain of that function. But at a later video, we will talk about domain as well. For now, just keep it here that zeros should be values within the domain of that function. For now, let's work together these two examples. Find the 0 of the following functions. Let's start with A. In order to find the zeros, I need to make f of x equal to 0. But then this means 3x minus 1 over x squared plus 4x plus 3 equals 0. A fraction is equal to 0 only when its numerator equals 0. So 3x minus 1 should be 0, from where it's easy to see that x is 1/3, and that should be the 0 of it. Now, in B, let's see something. Every single time, if we can factorize these rational functions, then we should start from there. I originally had 3x squared minus 2x. So it's x and then 3x minus 2. At the denominator, I should get x squared, so x plus 1 from the first, minus x plus 1 from the bottom. So this is important because I just found that there are no common factors on top and at the bottom. So it would be safe for me, in order to get the zeros, to continue working just with the numerator. So x times 3x minus 2 is 0. So either x is 0 or 3x minus 2 is 0. So either x is 0 or x is equal to 2/3, which means that this particular function had two different zeros. Remember again, before we are done with this video, that the zeros of a rational function, just take the numerator and make it equal to 0, but be extra careful whether this value makes or not the denominator equal to 0 as well. If it doesn't make the denominator equal to 0, then that's it. That was the 0 of the entire function. If the value we ended up as a 0 also makes our denominator equal to 0, then we would have to reject it, because we would say, and we would do that in the following video, we would say that this is not even part of the function's domain. That's all for now. Please go over again and again and again, as many times as you need, as you feel is needed, this video. If, however, you still have concerns, you still have questions, don't be shy. Just leave them in the section in the comment area below. As always, thank you for watching.